you can spend money on as well. Cool. And then as a note, we're recording for YouTube later on. But yeah, the car has wheels. Cool. It's fast. Awesome. Any other things you'd use to describe this car? What kind of company is it? What kind of color is it? Maybe whatever else. Lambo, nice. People picked up on the logo there. Definitely a distinctive design as well, right? Yeah, so other things I would use, right, is it's black, it's green, a neon green kind of thing. And so I think it's interesting to see that all of like everybody that commented in the chat and things had like almost two distinct categories that our like responses fell into, right? Many of us described it in like context of its visual attributes. So we had things like color, we had things like brand, we had things like I don't know how big it is, what like the shape of it, right? But then we also had things that were referring to more like functional features, right? Whether it's fast, whether it has things like wheels, it goes vroom vroom, and so those kinds of things were referring to more functional kind of thing attributes. And so the kind of big like point I wanted to drive home here is kind of how we go about thinking this changes our perception of these objects. And so, of course, this car does not look as cool as the Lambo, but I'm going to use it to illustrate a bit about what object-oriented programming is really all about, right? And so for now, you can ignore this word class. We'll get back to what class means. But yeah, you can think about this car, right? And the car that we just looked at, it has all of these things, right, on the slide. So it has things like it has some fuel level. It has some kind of max speed, right? Considering that this car is a Lambo, it probably has a really high max speed. And so you can kind of keep that in mind. These are more like static attributes, right? They might change over time, but they might have some sort of value or something. So you can think of them as like internal to the car's state. And then you also have methods. So some of you touched on this with like going fast and whatever else, right? So you can set the speed of the car. You can get the speed of the car. You can refuel the car. You can drive the car, whatever else, right? So these are more kind of actions that you can do upon the car object. And so these are the two kind of buckets of I guess, items we'll be considering when it comes to object-oriented programming is these attributes and these methods. And we'll be trying to think about the world from this perspective for every single object that we kind of come across, right? And so a car is one of those types of objects. And so this is the abstract way of looking at a car. You can imagine that this applies to not just a Lambo, but this can apply to many more cars. And so you could imagine that we might define this abstract concept of car, and then we might have, let's say, a Volkswagen. We might have a Beetle. We might have whatever else, right? A Toyota, Ford, whatever kind of car. And all of those can have specific instances. And so that gets into the kind of second concept I want to touch on here, is this concept of instantiation, right? So we define this concept of a class, where a class is this abstract kind of car object. And we're not referring to anything concrete here, right? We're just defining this kind of blueprint of what a car really is. And then we're defining specific instances of that car as objects. So on the right-hand side here, you can see a bunch of objects being defined. And each of those objects can have its own values for each of these things. So you can imagine like a Beetle, for example, might have a different fuel value than a Toyota car might have. And so the car that I own might have something different than the car that you own, for example. And so that kind of touches on this concept of instantiation in object programming. And so that going back to what a class is basically at a high level, really a kind of way to describe some abstract concept in a way that is quite generic, right? That extends well to being able to create multiple instances of that object. And for those instances to have their own state, for those instances to have their own methods, right? You can drive each of these cars and whatever else. Cool. So I'm going to stop there for a bit. Does anyone have any questions? Feel free to unmute or put them in the chat. Okay. I'm going to assume that means that everybody is super crystal clear on what's happening. And yeah, this is going well so far. So if we proceed, so again, so looking at it with an object-oriented lens now, I want to just go through some of these examples of different objects. So let's start off on the left over here. If we consider this table, right? Could people like drop in the chat or unmute and tell me, let's start with attributes of this table, right? What are some attributes that a table might have? Feel free to come up with anything crazy and wild that a table might have. Number of legs. I like it. Yeah, I've seen some creative tables, right, with 3 legs, 4 legs. I don't know if but yeah, 1-leg tables do exist as well, right? You just have like a big solid leg in the middle and stuff. So definitely some interesting ways of doing tables. I know I tried to set up an IKEA table recently that had like, I don't know, like these 4 legs that are like intertwining, right? They look super cool, but it was like a super painful thing to assemble. And so, yeah, I don't know, that's just artistic side of things. So from Sarah, we have top surface. So I assume you're referring to kind of the material of the top surface there. Is that correct? Like wood versus metal versus glass, whatever else. Okay, awesome. Yeah, definitely relevant, right? I think, yeah, wood, glass, metal are all common types of surfaces that you might have. Any other attributes that people have here? Okay, awesome. For now, we'll move on to methods. So what are some methods you could define on this table, right? Again, feel free to be as abstract as you want to be. Doesn't need to be reasonable stuff, just anything you could define. Any thoughts there? Like one thing I'm thinking about right now, right, is just moving the table. You could have some method that's like move table. If you wanted to be really fancy, you could define some sort of XY coordinate that you're moving the table to, kind of thing. Fold up, that's a good one, right? Many tables can be foldable. You can imagine that fold up might actually go hand in hand with like some sort of state that you're maintaining, like attribute. Like you might have folded as being like a Boolean variable that's keeping track of whether a table is folded or not. And then when you call this method, you'll be changing that Boolean variable accordingly. Awesome. Any other methods there on a table? Cool. So just thinking about other methods, I guess demolish, right, could be another one similar along the lines of fold up and stuff. I am trying to think of other ones. I guess there's not that many things to do with table. I guess you can put stuff on a table, right? I think that could be another one you could do here is if you want to keep track of what stuff is on the table, you can have methods for like place cornflakes on the table or something, right? And like other things. So yeah, I won't go through each of these examples here, but I think it can be a useful exercise to think about like what kind of things does a fan have? What kind of things does a motorcycle have, pen have, and keyboard have, right? You define each of these things in an object-oriented kind of way. So a fan, for example, you could like have methods such as speed up or slow down kind of thing, right? You have attributes such as color, you have attributes such as wattage or wherever else. Similarly for motorcycle, you can have pretty much all of those things. And the keyboard and pen of course, might be a bit different. You can be storing whether a pen is open or not kind of thing. A keyboard, you can be storing like the keyboard layout and stuff like that, right? So you can see how these kinds of concepts can apply to real world objects. And so if we move on to the next slide. So yeah, this is just kind of bringing it back. This is mostly just touching on a bunch of terms. You might see all of these words being used in like different places. We have property, attribute, or state. For my purposes for now, we'll be considering them to largely be interchangeable. I think there's differences when it gets down to like particular philosophies or programming languages you encounter. But yeah, they're all largely referring to the same sort of idea here. If you get into like React, for example, state refers to a very specific thing within React. But yeah, we won't touch on that for now. And then we have methods. So methods may also be called like functions or procedures sometimes. And you can think of them like largely as being actions kind of on something. Again, each of these words might have different connotations depending on which language you're using. But yeah, at a high level, we have these two things defining the object. So yeah, this is kind of an example of combining all of those ideas that we just went through, right? If we look at an example of a book, right? We have these properties like a title, author, and pages. We have methods such as read and buy. And here you can see some examples, right? The Giver, Fox and Socks, A Wrinkle in Time. As a side note, what are people's favorite books, right? Would love to learn what people's favorite books are in the chat. Try to get some reading recommendations as well, you know. One of my favorites of all time is definitely the Harry Potter series. But yeah, feel free to drop it in the chat. But yeah, going back to the example, you can think about like this example, right, touches at some more things as well that you can define. Like you might think that might want to define this universe. So if we define this method buy, for example, buying a book, you can imagine has like some consequences, right? Buying a book should probably decrease the book's count in some sort of inventory. It should probably decrease your money that you have in your hands, for example, and increase the amount of money that a merchant might have. And so that's like changing a bunch of things there, but you can imagine that each of those things could be a model, right? You could be like some sort of object. The merchant could be some sort of object. You're storing some sort of inventory. So like, let's say we have a bookstore object that's storing some sort of like book count. And now we're decrementing or incrementing the count on that bookstore object, right? And so you can kind of model all of these things as different objects and think about this as like an object-oriented kind of way where you're interacting between different objects as opposed to taking like a series of steps, right? Cool. So moving on. So this is just touching on that kind of concept in a visual kind of way. So you can imagine this might get very complicated, right? With modern software systems, what you're looking at is like millions of objects, right? You can imagine like Facebook or Twitter, right? Each of the users is modeled as an object. Each of these users is interacting with other users. And you have like all sorts of behaviors happening, right? People are liking posts. Posts are another object in this world. People might be commenting on posts. Comments are another object. And so you just have like these millions, if not billions of objects interacting with each other, where each object has its own state and attributes and stuff and its own behaviors. And so you can imagine this like graph gets very complicated very quickly. But each object at the same time is owning its own state, right? Which is what allows you to kind of do this in a pretty nice fashion, in the sense that it becomes a lot easier to think about things as opposed to trying to maintain like a global kind of state, right? Many of you might be used to doing that sort of thing. I know when I started off in CS, I was definitely like maintaining everything in global state and then just doing like a almost top-down kind of approach, right? When it came to like defining a set of steps that I go through when I'm defining my program. And so doing it in this way initially might seem kind of complicated. It's like, why would I do this if I only have 4 or 5 objects? But if you scale this up to millions or billions of objects, this allows you to think about it in a much cleaner kind of way. Cool. I'll pause there for a bit. Are there any questions so far? Cool. Okay, I'll take that as everybody's following and it's all good for now. Move on. So the concept that I just touched on is kind of this aspect of like procedural versus object-oriented programming. And so many of you, I know for myself, as I mentioned, procedural was like the first thing I was introduced to, right? The analogy for this is like you have an ingredient or like not an ingredient, a recipe of some sort. And so let's say you have a recipe to make some sort of chocolate cake. You're following that recipe. And that's kind of how you think about a computer program as well, right? A computer program is basically following a set of steps that you take to achieve some end goal. And so that like model works really well for smaller use cases. It doesn't really scale that well, as I mentioned, to millions and billions of objects. But yeah, here you can see the same kind of transaction being done in 2 different ways. On the left-hand side, you can see a procedural way of thinking about it. On the right-hand side, you can see an object-oriented way of thinking about it. So on the left-hand side, you can see like we have these different actions being defined: a withdrawal, a deposit, or transfer. You can imagine that this person is going to the bank, right? ATM of some sort. We have like these different things happening here. You can imagine each of these actions might map to like a specific set of steps that you would be taking in a procedural context. Whereas with the object-oriented approach, you wouldn't really have these specific set of steps, right? These might be defined as methods on these objects, but you'd have 3 different objects here. We have like customer, you have money, you have account, and money is, for example, moving between the customer and the account and wherever else. And so that's kind of more object-oriented way of looking at things. Cool. So that just touches on procedural versus object-oriented. So going back a bit, this is touching on the pros and cons, right? There's pros and cons here of using both procedural versus object-oriented. So with procedural, what generally happens is you have like top-down design, right? So you can imagine when you go into some example, like here, for example, withdrawal or depositing, you need to think about each of those steps, and you need to think about it from like a very holistic kind of point of view. And they might have like multiple objects interacting in there. You might have like a lot of different things happening, right? It might be complex. You might have a lot of business logic in there. And so what that also leads to is not much ability to do code reuse, right? Each of these things, a withdrawal and deposit, for example, have like money moving places, right? But if you define it in a procedural kind of way, you might not be able to define it easily, in such a way that you can reuse that transaction logic that you have that is common to both of these steps that you're doing. Whereas if you have object-oriented kind of design, you might be able to reuse that code, right? It's like a deposit is just money moving in this direction. A withdrawal is money moving in that other direction. But the fundamentals of how you move that money, right? Whether it's like a ATM, whatever transaction, whether it's an ACH transaction, wire payment, whatever else, right? There's a bunch of ways of moving money, where like Venmo, Zelle, whatever else. Then you can kind of abstract some of that stuff away, right? And so the kind of con of object oriented can be that it has complex design, right? As you saw with the diagram, kind of modeling the interactions between objects can get very complicated very quickly. And so just keeping track of which object is interacting with which object and whatever else, right, can get kind of hairy pretty quickly. But on the flip side, with procedural, you have complex code because you're basically defining this code at like a very top-down level, and you have like this massive file, perhaps. Like I know some of my early kind of procedural snippets and stuff definitely had this, where it was like this massive like 1,000 or 2,000 line file that just has like a ton of code, right? And it's super hard to grok because there's like specific code passing, look through and stuff. Whereas with object-oriented, generally what you'd be doing is splitting apart these files on the basis of each object. So you'd have like perhaps an account.py or something, right? Whatever language you're using. You might have money.py, you might have customer.py and stuff. And each of these files or objects and stuff has its own methods, its own attributes, and whatever else. So it kind of leads to less complex code, but more complex design because it's just a lot more stuff going on. And the last point here we touched on a bit is kind of this aspect of global data versus protected data. And so one of the big things with, you can imagine with like Facebook or Twitter or any of these like mass platforms like Google and stuff, right, is that you don't want anybody to be able to edit like any sort of data. And so you don't want to ever store like global state. And so that's like much harder to avoid with procedural, because procedural in, I guess, what's the best way to describe it? In essence, is trying to store everything in this global kind of state machine, where anybody can almost generally read any sort of data and also write any sort of data. You can try introducing some sort of complex like permissioning system and stuff, but it's just not like inherently easy to do it in that sort of design. Whereas with protected data, of course, you can define like each object, for example, has access to its own data. So if we go back here, for example, how much money the customer has is not known to the account, right? How much money you have in your purse, for example, is not known to the account. And how much money the account has, for example, may be known to you through some sort of permissioning scheme, but is not known to anybody else trying to access the account, right? And the way that you access that amount would probably be some sort of method on the account. And that method maybe would take in like some sort of PIN number, or taking some sort of other sensitive info that you'd use to access that account, right? And so it's not just like a free-for-all kind of thing when it comes to that. So yeah, that was just a whole bunch of content there. Wanted to stop again for a bit if there's any questions. So a question about where we could access the recorded workshop. I believe it will be posted on the YouTube 𝗏𝗏 channel. But yeah, 𝗏𝗏 perhaps to confirm as well. I think we'll follow up on this afterwards in Luma. Cool. Any other questions? They could be related to this. They could be like adjacent to this, tangential to this, whatever else, right? Cool. Okay. Cool. Thanks for confirming, Jennifer. We'll be sending out more info on recordings after this workshop. So yeah, the next thing I want to touch on are these like 4 pillars you might have heard of with object-oriented programming. And so we I forget their names. I think they're just known as the 4 pillars kind of thing. And I think they're like changing a bit kind of thing, but at a high level, you have abstraction, inheritance, encapsulation, and polymorphism. So all of these words might sound like really big terms, but I'm going to touch on each of these at a very high level. So we already touched on abstraction a bit, but abstraction is basically getting at this concept of like, you want to abstract away as much of that like minute work or unimportant work as you can, right? When you're interacting with a bank terminal or something, the user only really cares about like certain things, right? What the balance is, how, whether they can get money and stuff. They don't actually care about how this transaction is being executed at like the bit level, right? Or stuff like who are the parties involved with the transaction stuff. So you want to try to abstract away as much information as possible. That makes the program more secure. It also makes it less prone to error because you don't have just like random like entities editing data and stuff. And you're also exposing like some sort of very specific API, API meaning application programming interface, for anybody to interact with this sort of approach. The second thing here, we'll be going an example on this soon, is inheritance. And so this is touching on the concept of like, when you have objects, you might have objects that are very closely related, right? So let's say all of you guys here, for example, are students, right? We might be different types of students. We might be, for example, I'm a 𝗪𝗲𝗀 student. We have many Western students here and stuff, but student might be like this archetype kind of thing. So you can imagine like many things are common between students. Every single student, for example, has some sort of year that they're in. We're in first year, second year, whatever else. Each student might have, I don't know, some like tuition amount or something, right? They need to pay each year. So you have like these common attributes between different students. But of course, you might have specific things that are specific to 𝗪𝗀 or Western, right? You might have like courses and stuff. Courses may not be the best example, but what are some other things? I don't know, just like customs and stuff that you do, they're specific to each school, right? That you can think about, where inheritance is basically this like concept of defining some sort of abstract class that is like defines a student level object. And then you can get into like each like subclass of that is inheriting from this superclass, right? And so I think this will also make a lot more sense when we get an example here. Which, speaking of which, actually, let's take a break from the slides and get into examples. So let me move over here. Cool. Can everybody see the REPL screen? If anybody wants to confirm. Okay, I'm going to assume that people see the REPL. But yeah, REPL, by the way, if you guys haven't used it, REPL is a great website to use for any like quick sort of mockups and stuff. I've used it in the past for like, I don't know, just quick scripts and stuff I need to do when I don't want to spin anything up locally, or if I'm on a Chromebook or whatever else, right? Something where it's hard to do stuff locally. And I think more recently they have like a lot of crazy features as well. But yeah, I'll be just using this as an example for this workshop. So I want to touch a bit on this concept of like inheritance, and also let's like get into the concept of classes and stuff more broadly. So here I have like, awesome, thanks for confirming, Kelly. This concept of like a rectangle, right? So I touched on like these objects and stuff. So here we have a rectangle, right? A very basic kind of object. And so this is how you would define objects in Python. Each language has its own way of defining objects. Java, for example, does it slightly differently. C++ does it slightly differently. But in essence, all of them are like quite similar. They all have these like attributes and methods and stuff. So yeah, let's just go through what this program is doing right now. If we start down here, we're defining this rectangle, right, of and assigning to this variable R1, which R1 is now like pointing to some rectangle in memory, right? And if we look at what a rectangle is, we have this like special init method, right? Some of you might have seen this before. But yeah, init is this Python keyword that you can use for kind of defining the class initializer. And so that's why it's called init. But yeah, it's taking in these three different arguments here, right? So we're taking in the length and the width of the rectangle. And self is kind of a special keyword that actually references the instance of the class itself. So in this case, R1, for example, is an instance of a rectangle. And so R1 is basically being passed in as a self argument here. And that's just for Python to know, like, what is the concrete instance of this class that I'm referring to. And so if we go in here, it's a bit weird, but the kind of notation to do this in the Python is we're assigning like some instance level variables to these arguments that are being passed in, right? So we have length and width being passed in. We're now assigning them to these instance level variables. So this length and this length is actually quite different. But yeah, we're assigning this length over to the instance level variable, and we're doing a similar sort of thing for width. If we move on over to area, we can see that this is a method that we're defining on this class. So the area of rectangle, of course, is the length times the width. So you can see here we're referencing these instance level variables here. And kind of a related note here is that you can have things like instance level variables. You can also have like class level variables, right? So if you go over here, let's say, what's something common to all rectangles? I don't know, I'm just gonna like type in foo equal to bar for now. You can try to think of other things that are common to all rectangles. Yeah, let's say we wanted all of our rectangles to be black, right? Doesn't matter what color or what user instantiates them. I just make them all black. So we can have something like this. So the way that you can use this is we have color self, and then you can return something like self dot color. This is maybe not the best nomenclature since, yeah, you can kind of see. So here we can actually do two different things. We can do r1.color. We can do r1.color with open parentheses, and these will be referencing two slightly different things. Oh, nice. Okay. So why this failed here was because I'm referencing r1.color here, which is going into this method that call here that goes down to self.color. This goes back into this method call. And so this is like one reason not to have namespace collisions between like your methods and your variables, because sometimes it can just make it a bit hard to understand what's happening. The main reason for this is these open parentheses here. I don't want to call the method again. That's going to lead to like infinite recursion here, where I'm calling the same method again and again. If I remove this, then I will see what I expect, right? And did we expect this? This is returning a bound method of some rectangle. So if we go here, it seems like the method is taking precedence over the field. So if we change this to something like get color, like this, and then change this over here, try this out. Cool. So here we can see that's what we expected to kind of see black. So you can see there's like two ways of accessing this. Generally, it's like pretty frowned upon to access a field directly. This is kind of violating the second, like one of the things that you saw in the slides was this aspect of like encapsulation. So with this example, we're, oh shoot, let me X this out. We're violating encapsulation here, since we're directly accessing like some internal state, right, to the class, which may or may not be okay. In this case, it's probably okay for somebody to know what the color is. We can imagine like more nefarious things. Somebody might like go ahead and change the color directly at a class level and stuff. But yeah, that was a whole bunch of stuff. Let me pause there for a bit. Are there any questions on like defining objects within Python? And then I'll get into what inheritance is in this context. Or if anybody's following along with the code here as well, let me know if anybody's having any troubles kind of running this as well and can jump in to help. Cool. Okay, I'm going to take that as everybody is following along and it makes sense. So if we move on, I'm going to stick to this for now, since I think it's just more engaging to talk about this with code. So if we talk about inheritance here, right? So let's say now we have the concept of a square. So a square is, I guess, depending on who you ask and stuff, you can think about it as a rectangle of sorts, right? I'm sure some math purists out there might come at me for that, but yeah, for now, let's say a square is a special type of rectangle, right? Which it really mostly is. And so let's say now a square is inheriting from a rectangle. So the way you can do that within Python is this kind of syntax, where we're now saying this class square is a subclass of the superclass rectangle. And then what this allows us to do is we can define like its own initialization methods, right, if we need to. So let's say init, we have something like self, and then we know that a square doesn't have a different length or width, right? So we can just say something like, I don't know, just side length or something, for example, right? So now here you can say something like self dot So you can get into, actually, I guess, yeah. So if we want to reuse some of the code here, we can do rectangle.init here, and then call this with the relevant arguments. So in this case, it would be self side side, because we know that the length and width are the same. And then you can do whatever else you want to define here, right? So let's say, for example, what's another thing we define on a square? Pattern, right? So let's say pattern is equal to self.pattern is equal to pattern. So this could be like dotted or something like that, or striped and stuff. So we're defining some sort of pattern on this rectangle. And then we automatically get some of these where like methods for free, right? So if we now define a square, let's say S1 is equal to a square. Let's make that have a side of 4, and then let's make it dotted. We're not really using this for now. And then let's do S1.area, and let's try this out. Cool. So you can see the last output there on the right is 16. And so just following what we did there, S1.area is actually referring to the superclasses method. Since we haven't actually overridden the method, we could override the method if we wanted to. We want to do something like def area self, and then define some sort of method here. And it would this would take precedence over whatever the superclass has. But yeah, we're using the superclasses method here. How this init method worked was that we called the superclass using this kind of rectangle .init notation with self side side. And then we also set like a new field that we care about with pattern. Cool. Does that all make sense with inheritance? Oh shoot. Okay, I missed a comment from Sarah. What's the difference between line 19 and 20? Are these two lines you're referring to, Sarah? With rectangle.init and self.pattern? Or was it somewhere else before we got? Okay, yeah. So, okay, that's a good question. So that was a bit confusing, mostly due to the way that I named things. But what we had here before was r1.color here. So the main difference between these two lines, so we had something like this, print r1.color. Besides the fact that like Python, for example, was binding the color to the method itself, was that this is referring to directly accessing the class level variable. And this second thing is not directly accessing the class level variable. It's calling a method on the instance, right? And so you can do this sort of direct access for a class level variable. You can also do it for instance level variable, right? So for instance level variable, an example of this is something like s1.length, for example, right? So if we did this, what we expected to see is 4. So here we're seeing that we haven't defined like an explicit sort of method for getting access to the length, but implicitly within Python, you can just directly access the length. This, to be honest, is one of the shortcomings of Python. It doesn't actually have like super nice ability to do permissions for like different sorts of state. So in Java or C++, for example, you can have like private versus public state. Within Python, there's no like super great ways to do this. The normal convention within Python is normally to add something. So let's say we had like some private variable and we wanted to make color private. Normally, this is what you would do, is add an underscore before the variable. And normally the convention within Python is to just not reference anything that has an underscore with it, because underscores are meant to be private state, for example. You can also use this for like private functions, for example. But yeah, it is unfortunate that this is not enforced within Python. There are some like third-party libraries that like help you enforce this within Python. Like I think MyPy and some other things help you do this, where like, for example, if you try accessing something with the underscore, it will scream at you. And vice versa, if you define something and you don't use it, then it will require you to use an underscore. But yeah, does that make sense, Sarah? Touching on this question. Cool, awesome. But yeah, great question. And I think that just goes to show like, try not to mix up your names too much and get kind of confusing. But the good thing with this as well, right, is that you can imagine that like, if you have different objects and all of these objects have their own color, right? Like, let's say shapes have colors, right? So shapes have colors. tables might have colors as well, right? A car might have colors and stuff. All of these can have their own dot color kind of methods or their own dot color fields and stuff. And you still don't have any namespace collisions between these because they're defined on like the instance or object level. If you did it with a procedural approach, where you are like trying to define colors at like in a global state object, right? You can imagine that would blow up very quickly because you have like color car, you have color shape, you have color X, whatever, right? So that gets like very painful to kind of manage. Cool. Yeah, if there's no other questions on that front, we can get back to slides for a little bit and then come back to the code soon. So we just shoot, okay, I'm not sure if this was to present. Let me go over here. Okay, so we just recently touched on this aspect. Let me remove this as well. Of abstraction. We touched on inheritance a bit. Encapsulation, I talked about that a bit. That's mostly referring to this concept of like public versus private data, and wanting any kind of data that's relevant to some object being within the object. And accessible only to the object, which makes it a lot safer and a lot simpler to kind of deal with as well. And then the last thing that sounds really complicated, polymorphism, is basically just, I guess, like quite related to abstraction in a way. It's referring to this concept of like trying to program things that can be used in multiple ways. So I think one of the best examples of this is if you guys have done like a lot of React, right? React is this front-end framework kind of thing. Even if you haven't done React, I'll just describe what I'm talking about here for a second. Is you have like this concept of components, right? Any page has a component, and all these components have this like common method of rendering. And you have a bunch of logic that goes around this render method. React has a bunch of cool stuff around like how to compute steps and everything else. And so that's a good example of polymorphism where you're defining this like generic concept of a component, right? And stuff, and with this render method. But you're using it across all these different use cases and stuff. And so trying to define things that can be commonly used in many different places and are generic is kind of what it's touching at there. And yeah, as a side note, React and JavaScript generally is considered more functional, depending on the way they use it. And all the class like syntax actually boils down into functional syntax. But yeah, I won't get too deep into that in this workshop. But if you are interested, we can talk a bit more about like functional programming versus object-oriented programming as well in the future. But yeah, why use object programming? I think I'll skip this for now. I'm not sure if my audio works here, but this is a pretty funny clip from SpongeBob, which of course was my favorite shows from childhood, right? So we recommend watching this if you guys haven't seen it before. But TLDR is Plankton tells Patrick to just go. I forget what he's trying to do. I think it's pull Walt into like a pit with something, just because he said so. So yeah, it's my number one reason for using object programming. But yeah, some of the other reasons for using it. Modularizing the program, we talked about this a bit already. Cleaner code, custom objects, we talked about this already. Creating data types that are not defined within language. It's a pretty cool thing you can do, right? So I touched on this a bit, but here you can see, for example, like rectangle is like not a standard Python data type, right? Like it's not like a rectangle is like a built-in data type within Python, like similar to integer or float or whatever else. But you can now use it as like a built-in data type, right? Similar to how integers have like some methods defined on integers. You can round an integer, you can do whatever else and stuff. Now we created our own custom object or type, basically, that we're dealing with. And so here you can actually use, I believe in Python, it's actually type S1. I might be wrong. I've been doing a lot of more TypeScript and stuff more recently. But yeah, cool. So you can try it like using the type keyword there, which gives you the type of like any object. So you can see the type of this object S1 is actually a square. Whereas if you do something like print type 1, for example, we'd expect that to be an integer, right? So here you can see this is an integer. And so this is allowing you to create your own custom types, basically. And then you can, as I mentioned, definition of classes can be used by other programs. And you cannot accidentally access the data of another object. And yeah, I thought this was a pretty fun graphic that one of my profs showed me way back when. Actually, but yeah, this is the world as seen through object-oriented programmer kind of lens, right? You have the TV as an entertainment provider singleton. A singleton in this context is referring to something that you only have one instance of. You'll see this around like CS context as well. You have like the thirst quencher container, which is just a glass of water. You have the entertainment provider view controller, which is the remote control, right? The living space separation decoration, which can be art. Privacy manager delegate, which is controlling your privacy with the window and stuff. Multi-butt supporter, this is a fun one as well. And then yeah, some other examples here as well of other objects. Cool. And then we touched on this already. This was just getting into more examples. Dog, going to examples here. Cool. And then this is a good way to look at inheritance. So we might have some like more complicated inheritance as well, right? We have vehicles. They might have like bikes, cars, buses, trucks, wherever else. And then that goes down to subclasses of like pedal bikes, motorbikes, pickups, vans, sport cars, and whatever, right? Each of these might have their own specific business logic that they worry about. But at the top level, all vehicles, for example, might have something like number of wheels, right? And that kind of stuff. But cars and trucks, for example, might have like fuel, whereas a bike doesn't really have fuel. But a bike might have like, doesn't need an oil change or something like that, right? So other things like that. So yeah, that's a kind of way of kind of visualizing inheritance. Another point to touch on here is that the another concept that's been getting more popularity in recent times with kind of object-oriented stuff is this concept of composition. And so composition touches on a kind of different way to look at inheritance. And so inheritance is kind of, you have superclasses, subclasses, whatever else, right? Composition is more so if you have a collection of objects that you can combine together, like compose in some sort of way to create a mega object. That's kind of how you're thinking about composition. So that allows you to also do code reuse, but is potentially easier to think about, especially when you get into like more complicated hierarchies of inheritance, because that can get pretty complicated pretty quickly. And so it's just another trend that's becoming more popular in more recent times, especially in like front end context, for example, and starting to pick up steam in back end context as well. But yeah, and then we touched on this already. Cool. So I want to leave a bunch of time at the end for a bunch of questions, or we can go deeper into some examples here as well for any like areas people want to get deeper into. But yeah, if there's any questions about the workshop, any questions about whatever else, right? Questions about anything I've done in the past and stuff. Any questions about hackathons, right? Whatever else, my experiences with hackathons and stuff. Feel free to shoot them now. We have like 8 minutes left, I think. Yeah, feel free to unmute or shoot them in the chat. But as a side note, as people are thinking of it, if they have any questions, there's definitely a lot of like great resources out there to learn more about object-oriented stuff. If you just search up object-oriented like tutorials or something on Google, right, you can find a bunch of stuff. I personally did, I think it was called, edX had a course, I'm not sure if it's still offered, but MIT 6.001X was a course that I did this a while back, but that like goes through a great like overview of object programming, specifically with Python. But yeah, Java is probably the canonical language to do object-oriented stuff in, or C++, just because it has like much better constructs in to some extent for this sort of thing. But yeah, so there's a lot of resources out there that I would encourage you guys to take advantage of. But definitely quite a relevant skill, because I think I would want to say like 90 to 95% of like industry nowadays is mostly object-oriented. Front end, of course, is a bit of the Wild West when it comes to like different paradigms that are being followed. You have like a bunch of functional, you have a bunch of like whoever knows what's happening kind of thing. But yeah, at least in backend land, I would say it's mostly still object-oriented. There are some notable exceptions with front end, or functional stuff, but yeah. Any questions about hackathons, whatever else and stuff? Otherwise, we can cut it short as well in a couple minutes. But yeah, I guess while people are here, if you guys are interested in my Hack Western projects, I'm trying to think about what they were. I think hack question 3 we made. It was a medical focused hack. It was around, if I remember correctly, connecting walk-in patient clinics to the nearest walk-in clinic that has a low wait time. We had some sort of punny name for that. Let me see if I can find it actually. It's I think fun to look at. Let's see. We'll be down here somewhere. Yeah. And patient. This is one of my first projects ever. Hack question 3. Okay. So it wasn't hack question 4. But yeah, you can see like our interface somewhere here. Very rudimentary, right? Did not have a clue what graphical design was back then. Was using tkinter with Python, but it worked, and so we're proud that it worked. And it's one of my first times integrating with like an API and stuff. We were using the I think Google Maps API for like getting nearby walking clinics and stuff, and then storing like some sort of state on our side with Heroku. And then keeping track of times and stuff to see like a schedule of like these slots have been booked out and the nearest walking place that you can go to and stuff. And so that was pretty fun. And then I'm trying to think about like what other, I think the other Hack Western one, where'd it go? This one. This was like Hack Western 6, was driver's side. This was a really fun one. Shoot, we don't have a photo here, but this is a fun one to test because we basically created like a virtual driving assistant that uses computer vision to keep track of where you're looking, right? If you're looking to the left, if you're looking to the right and stuff. So you can imagine if you're driving a car, you basically have this in front of you, and it keeps track of if you're actually looking to the left or right for doing different turns and stuff. So if you're about to do a left turn, of course, you should be checking both directions and stuff. Or if you're at a stop sign or something, checking both directions as well. Some interesting stuff there again with like APIs and like face detection and like features on faces is very hard and painful because it can be quite noisy. And so that's kind of fun to deal with here. But yeah, cool. Okay, let's go. I see some questions in the chat. High level overview of how you structured the code. Arthur, is that a question for these projects or is that a question for like this code example?
Yeah, for like the Hack Western projects.
Okay, nice. Yeah, so okay, these might be a bit harder to think about how I structured the code. I can go to a more recent one, perhaps. Let's go over to okay, Pebble Prompter is probably a good one to talk about. Yeah, this is also not super recent, but yeah, Pebble Prompter was this like automated teleprompter where yeah, this like tells you where you are with speech, and it's trying to keep track of you in a speech using like text to speech and stuff. But yeah, going to your question, how to think about the code here. So there's a few different parts with this project. We had like the smartwatch component, right? We had the laptop component, and then we had like this like API layer, right? So I think that thinking about like these different purposes and stuff is a good way to get your like initial splitting points with the project. So you have like this API component that like myself, for example, I was working on the API piece. Leon was working on this like watch piece, I believe, and then Taras was working on this UI piece stuff with the watch. And so I think that can be a good way to like think about the different like purposes or goals you're trying to achieve with the project. You normally have like a few different goals, right? And then split it amongst that kind of way. If you're trying to get into like a deeper level of like how to actually split apart the project, I think there's definitely like, I guess, a few different loops you can define, right? Like what are the critical loops to your application? In this case, it's like the loop of like detecting whatever the user is saying and then transcribing that into text and then figuring out where you are in the speech and showing that to the user, right? And so each of those things is like a single step. So each of those things could also be an object of sorts, right? So you have like your API manager that is talking with the API. You have your like speech manager that like has your keeps track of your speech and whatever else. And you're like going through some sort of text object there and stuff. So you can kind of see how those interactions would work. But yeah, I think most of these repos as well should have some of the code links here. To be honest, I don't think some of my like hackathon projects are like the best examples of code design, right? And that's a note for you guys as well. I don't think you should be focusing too much on code design. Like try to have reasonable code design at hackathon. But at least for myself, the goal at hackathon was always to like build something quickly, right? Prototype something quickly, learn a lot of stuff, And code design can be something you can focus on as well. But yeah, I would say like a lot more of the projects that I've worked on at like internships and stuff have been a lot cleaner in terms of how they're structured compared to a hackathon project, which is like somewhat scrappy, right? In the way that it's built. But yeah, hopefully that answered that question. And then Thomas is asking, what programming language do people usually use at hackathons? It's all sorts of things, right? Like I think going through some of these projects, some Node, this is mainly like TypeScript, React. We had like Node backend and stuff. Timeline was similar kind of stack. Pebble Prompter had some C++ for some of the smartwatch components. And then Python here as well. Simplify has some driver level code as well, which is interesting. So I think all sorts of stuff. I would say most popular I've seen so far probably been like JavaScript, TypeScript, and stuff, along with like Python and maybe Java, and stuff. Or if you're using Unity, for example, this was like written with Unity. C# is like pretty popular there, right? With Unity, you can do some like cool stuff with games and stuff that you can play around with. So yeah, I would recommend like checking out a bunch of frameworks because there's a lot of cool stuff out there. Cool. Hopefully that answers some of those questions. And I think we're pretty much at time. So I'll be sticking around for a bit if anybody has any more questions. But thanks a lot for coming out. Hopefully this was useful for you guys. And I believe we'll be posting a recording somewhat soon at some point. Let me stop screen sharing so I can see some faces as well.